Hello students, welcome to IMS GATE Academy. Welcome to IMS GATE Academy. We are discussing the foundation course of engineering mechanics. So as of you all know that, right? Now here, so up to statistics we have finished. Now we are entering into the dynamics of engineering mechanics. It is very important for the mechanical engineering students. Okay, as of all of you know that myself, I'm Dr. Vijaya Kumar. I'm going to teach you foundation course of engineering mechanics for grade 24-25 aspirants, and also today's our topic is dynamics. In that dynamics, we are going to discuss about dynamics of particles. All right, guys, right? Let's go for the session. That is dynamics of particles. Okay, right. Now, before going to discuss about so dynamics of particles and dynamics of rigid bodies, we need to first understand that what is dynamics. In that dynamics part, what we are going to cover, that is what we would like to highlight, right? So as we have in the beginning itself, I told you and I gave you one block diagram also, right? Now here, so today's is dynamics, and so this dynamics is divided into two parts. So what about dynamics? Dynamics is nothing but study a body when it is in motion, that we already know. So static means when the body is in rest position, then whatever the study we have studied, and that means what are the effects of the force on the body when it is in rest, that is come under statistics, right? Dynamics means whenever you apply the forces on the body and it is in motion. Now, if you study the effects of body under the action of external force when it is in motion, that is come under dynamics, isn't it, guys? Okay, right. Now let me correct this. Right. Dynamics, right? These dynamics part is divided into two categories, right? So two broadly categories. So first one is kinematics and second one is kinetics, right? Now first one is kinematics and second one is the kinetics. Second one is kinetics, right? Now what is kinematics and what is kinetics? Okay. When the body is in motion, if you study the effects of body without considering the force which is caused for the motion, that is come under kinematics. All right, I just repeat the statement. If you study the body effects when the body is in motion and without considering the forces which is caused for the motion, that is come under kinematics. All right, suppose say that here one football is there, right? So it is having certain mass. Okay, now so if you kick the football, then it is going to be up certain height, and after that it will reach to the down, right? So now here while you are kicking the football, you are applying the force. So if you apply the force, then only the football is in motion, right? Now but here in kinematics what happened now, we are not considering the forces, okay, which is cause for the motion. So that force we are neglecting and we study the effects of the body, that is come under kinematics. Okay, study the body under the action of forces. Now let me give you the statement of kinematics. Right. So now here I just highlight kinematics. Study the body, study the effects of body under the action of external force, under the action of external forces, under the action of external forces when the body is in motion, when body in motion without forces, is come under kinematics. I hope everybody understand. So right, whichever the force is caused for the motion of the body, if you are not considering that force while studying the body, then it is come under kinematics. All right. Now similarly kinetics, here I am unable to write the definition of kinetics or statement of kinetics, so that I just go for the next slide and I'll write there. Okay, right. Next is kinetics. Kinetics. Okay, study the body study the effects of the body under the action of external forces when it is in motion by considering the forces is come under kinetics, right. Now let me write that, right. It's a study the effects of body, study the effects of body, study the effects of body under the action of external forces, under the action of external forces, under the action of external forces when the body is in motion, when the body is in motion by considering the forces, by considering forces, by considering forces, right. So then it is come under kinetics, isn't it, guys? I hope everybody understands. Study the effects of the body under the action of external forces when the body is in motion by considering the forces, kinetics, and without considering the forces, same definition, it's come under kinematics, right, guys? I hope I have simplified that. Dynamics means here body is in motion, body is in motion, body is in motion. Yes, guys. Okay, that is what dynamics. Now in the dynamics we have divided kinematics and kinetics. All right. Now let us move for another concept, that is types of motions of a body. So here how many motions the body is having, right? So when the body is in motion, so how many types of motions are there? Okay, types of motions in a plane. Okay, our topic is types of motions in a plane, right. Now here types of motions in a plane, right. So now here the body is moving in only one plane, that is xy plane. That means either it may move. So here if you consider this xy plane, so the body is moving in this plane only. So when the body is moving in a plane, how many types of motions it is having? So that is what I would like to highlight and describe you in proper way. Okay, right. Now here we have so translation motion, rotation motion, and general motion. Three motions are there. Okay, so first one is translation. First motion is translation motion. First one is translation motion, right. Second one is rotation motion. Rotation motion, right. Now, so here rotation we indicate with R and translation we indicate with T. All right, guys, right. Similarly, third one is a general motion. General motion. Third one is a general motion. All right, guys, right. So in translation again we have two types, rectilinear motion as well as the curvilinear motion. Here again it is having two types, rectilinear motion, curvilinear motion. Rectilinear motion, and the second one is a curvilinear motion. All right. So first of all, we understand the motions of the body when it is in motion. So if you understand these kind of motions, so that it would be very easy for you to solve the problems and understand the problems in the dynamics, right. In the dynamics, how to study the kinematics of particle and kinetics of particle, and kinematics of rigid bodies and kinematics of kinetics of rigid bodies. If you want to understand all these things, it is very essential to understand these concepts. That is, what is a translation motion, what is a rotational motion, what is a general motion. So generally general motion is a combination of translation plus rotation. I will let you know, not an issue. Okay, right. Now we will highlight that. First one is rectilinear motion, rectilinear translation motion. First we will highlight that rectilinear translation motion, right. So first one is the rectilinear rectilinear translation motion. It's a one type of translation only, na? That is why I'm adding this word translation, right? Rectilinear translation motion. It's a very simple and easy, okay? It's a very simple and easy, right? Now let me go for this. Right now here, suppose say that, right now, what is rectilinear translation motion? Suppose if you consider a body, so in the body so many particles are there, so all the particles of the body move in a identical and parallel path and which are having same velocity, then we are considering it as a rectilinear motion. What is that? So all the particles of the body move with a identical parallel path and all the particles having the same velocity, then it is considered as a rectilinear motion. Okay, now let me give you that. Right now here, right, if all the particles of body, if all the particles of body, if all particles of body are move with, oh my god, or move with, or moves with identical parallel paths, and all particles having same velocity. All particles have same velocity. All particles have same velocity. Isn't it, guys? Right? Right? This is what happening, right? So in order to understand this, I will give you one example. If all particles of the body are moves with identical parallel paths and all particles having the same velocity, then it is considered as a rectilinear translation motion. Okay, so hope you understand, guys. Hope you understand. Right, now let me give you one example of this. Okay, so let me give you one example in order to understand this. Okay, right. Now here, see guys, and then I will take a body, say that this is one body, right? Now it is moving with certain velocity. It is moving with certain velocity. It is moving with certain velocity, say, okay, and finally it reaches the position over here. Finally it reaches the position over here. Right? Right, guys, right. Right. Now here in this case, what I am going to do now, so here I am taking two particles, say this is particle 1 and say this is particle 2, right. So now these two particles in the body, right, so many particles are there, but for in order to describe you, in order to clear you the rectilinear translation motion, I am taking two particles of the body, right. These two particles are move with, 1 minute, these particles of right. Now see, first particle, so move with the, in this case, right. Now second particles also, so move parallelly like this and reaches this position, right. Now here what happened now, so say this is a 1 dash and say this is a 2 dash position of these particles, isn't it, guys? Okay, so now here what I'm trying to explain you, if two particles of the body, that means if all particles of the body moving with a parallel paths, parallel paths and are having same velocity, then we are saying that this motion we are calling it as a rectilinear translation motion. Okay, in simple words, rectilinear motion is nothing but if it is the body moves in a straight, in a in a horizontal way or in a vertical way, then it is considered as a rectilinear motion. But in rectilinear motion, the particles in the body having the same paths parallel to each other, and velocity of each particle is equal. That means see that, so velocity 1 particle is equal to velocity 2 particle. So this is what I am going to highlight, right? Now the distance is traveled by the two particles is also same. So say suppose this is the displacement, right? So displacement is also equal to same. Wherever the velocity is same, then displacement is also same. I hope I have simplified the rectilinear motion. Clear everybody, guys? Clear everybody? So hope you understand, right? Now let us move for and here, so displacement means here, so 1 dash is equal to 2 dash. Okay, the distance traveled by the each particle is same, so that is why the velocity is also same. This kind of thing we are calling it as a rectilinear translation motion. If the body moving in this fashion, in this way, then we are considering it as a rectilinear translation motion. I hope everybody understand. Guys. Okay, all right. Now let us move for the next motion is curvilinear motion. Curvilinear translation 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 motion. Yes, guys, understood? Right. Now let me describe you these two also. Let me describe you these two, this also, right? Now, so here also it's very simple. When a body move in a curved path, all the particles having parallel to each other and having the same velocity, then we are calling it as a curvilinear translation motion. Okay, so all the particles of the body moving along the curved lines and both are parallel to each other, that means parallel to each other, and then if all particles are having the same velocity, then we are considering it as a curvilinear motion. Okay, now let me show you. So give you first statement and then we will move for the next. Okay, right, that is if all particles of body moves in curved path and also parallel to each other, parallel and so that's it, parallel and having same velocity is considered as a curvilinear translation motion. Here I will also show you what is a curvilinear motion. Okay, all right, guys, all right, right. Now in order to describe you the curvilinear motion, right, I will take right. Now see here. One minute, guys. Right. Right. See here, it is a curved path, right? Now here I am also taking a body. Here also I am taking a body, right. Now here this is my body. Either this body might be, you may consider it as a bike or car or whatever it is. Okay. Now here this is my let me 1 minute guys, 1 minute. So now, okay. So this is the body which is moving in a curved path. So now here it is a curved path. Here it is a curved path, guys. All right. So these curved path. Now here my body is moving. So I am taking two particles in this again. Okay. Now particle 1 and particle 2. Right. Now these two particles are going to be move onto this here, and here it is say that 1 dash. Right. Now similarly these particles also move like this. So now if the all the particles of the body, here I have considered only two, right. If all the particles of the body moving in a curved manner and the curved path also parallel to each other and these two particles are having the same velocity, then it is called curvilinear translation motion. Clear everybody, guys? So I hope I have simplified, right. So particle 1 and particle 2 in the body are moving with the certain velocity in a curved manner and the curved path is also parallel to each other, then we are considering it as a, what is that? Curvilinear translation motion. Okay. So now here also, now V1 is equal to, it is V2. That means velocity of the particle 1 is equal to velocity of the particle 2. Okay. Right here. So here we consider it as a 2D translation. Okay, here we consider it as a 2D translation. Why? Because see, it is a curved manner, na? So that is the reason why here velocity has to divide it into two components, horizontal component as well as vertical component, isn't it? Right. So here it is a VH and here it is a VV. That means horizontal velocity component and horizontal vertical component. That is why it is a 2D translation. In previous case, we call it as a 1D translation. Why? Because here the component of the velocity will be only one component, horizontal component only. I hope everybody understand. I hope everybody understand, guys. Okay, right. Now here let us see that. See, curvilinear motion we understand, right. Now here the displacement of 1 dash is equal to 2 dash. Here also the displacement is same. Clear everybody, guys? Clear everybody? Hope you understand. Hope you understand, all of you. Hope you understand, all of you. Okay, guys? Clear everybody? Right. Now let us move further. Let us move further. Rotational motion. Now let us move for the rotational motion. Okay, right. Now here we finished that. So translation in that rectilinear motion and curvilinear motion we finished. Now let us move for rotational and general motion, and then we will go for the variation, that means the variables of motion, and then we will solve some problems as well. Okay, right. Now let us move for rotational motion. Rotational motion. Rotational motion. Yes guys, say that rotational motion, right? How to find the rotational motion. All right guys, for rotational motion, right? Now here rotational motion means all the particles of the body moved in a curved manner, okay, in a curved path, but all the particles velocities is not going to be same. Okay, I just repeat the statement. So rotational motion is nothing but if all the particles of the body so moving in a curved path and the particles of velocity of body are different, then we consider it as a rotational motion, right? I will give you the statement. I'll move forward. Right. If all particles of body moves in a curved path, all right guys, moves in a curved path, and all particles having different velocity, all particles have different velocity, all particles having different velocity, it is considered you know rotational motion. It is considered rotational motion. It is considered rotational motion. All right friends, okay. So I hope everybody understand that what is rotational motion. That means the body particles are moving in a curved path and all the particles of the body having different velocities, then we can consider it as a rotational motion. Now let me explain you with the help of one example. Clear everybody? Right. Now let us go for one example in order to understand the rotational motion. All right. Now for that I am taking a shape. Right. Now here. So now here. Right. Here I am taking and one body. Right. Here I am taking one body, and this body is fixed here with a hinged support. Is fixed here with a hinged support. Right. Now see on this one I am taking this is what, right, like this, right. After that I am considering two particles. Okay. So here particle 1 in this body and here it is a particle 2 in the body, right. Now so with this fixed point, if I rotate this fellow, then see the body is trying to rotate in this manner, na? The body is going to be rotate in this manner, right. Try to understand guys, try to understand. Here I have taken one job, that means one object, it is fixed at one point, then if I apply moment here, it tries to rotate, isn't it, right? Up to here clear na? And I am considering two particles, particle 1 and particle 2, right. Now let us move for, if the body is reached over here, right. If the body is reached over here, right. Now this body is reached over here. Oh, right guys, right. Now suppose say that if I rotate like this, then the body is going to be rotated like this, right. Now here see, this is what the rotation axis, I will draw that. Here this is a rotation axis. Okay. Now it is rotated like this, right. Now when the body is rotated like this, obviously now let me take this. My particles 1 and 2. So now my particle 1 dash reached here and my particle 2 dash reached here, isn't it guys? So because of the rotation, my particle 1 is reached over here, my particle 2 is reached over here, right? Now let's draw the rotation of particle 1 and rotation of particle 2, right? Rotation of particle 1 and rotation of particle 2, right? So now it is going to be move like this. Okay, now let me draw it properly. Move like this, isn't it guys, right? Now here this is a path of 1 to 1 dash and path of 2 to 2 dash, isn't it guys, right? Now do you think that the displacement of displacement 1 dash, that means distance traveled by 1 dash is say S1, right? Displacement 2 dash is equal to S2. Now here is, do you think that S1 is equal to S2? That means distance traveled by the particle 1 is equal to distance traveled by the particle 2? No, not at all. Okay. So now here, so the displacement is not going to be same, right? So whenever displacement is varies with respect to time, then obviously velocities of particle 1 is not equal to velocity of particle 2. However, they are moving in a curved path, but the velocity of particle 1 is different, velocity of particle 2 is different. That is what our statement. Have a look on this statement. So what is the statement is given? If all particles of the body moves in a curved path, and the velocities of all the particles are different, then we are considering it as a rotational motion. Okay, so now try to understand the difference between the curvilinear motion and rotational motion. In curvilinear motion, what happened? The particles are moved in a curved path, but the velocity of each particle is same. But in rotational motion, what happened? So though all the particles are moving in a curved path, but the velocities of particles are different, right? Suppose say that here I am taking a 3 point and here I am taking the 4th point, right? So the distance traveled by the 3rd point is different, distance traveled by the 4th point is different, distance traveled by the 1st point is different, distance traveled by the 2nd point is also different. Whenever the displacement is going to be changed, then the velocity of the particle is also different, right? So now here all the particles are having velocity is different, but the thing is here their path is curved only, right? The body particles are moved in a curved path, but the velocity of all particles are different. That is why this motion I am considering it as a rotational motion. I hope everybody understand. Guys, right? Now here see it is a now I'll write the statement, right? Because of since displacements are different, of particles different, the velocity is also different. The velocity is also different, right? Now here particle 1 velocity is not equal to particle 2 velocity. Okay, particle 2 velocity, right? Here I can say that see here what happened. So displacement is less than 1 dash displacement is less than the 1 dash that means here so S2 is greater than S1. Similarly here also velocity is greater than velocity 1. Okay, I hope everybody understands. So the displacement one particle is traveled is 1 dash is less than the displacement traveled by the second particle, that is 2 dash is greater than that of the first particle. Then the velocity is more for the second particle, velocity is less for the first particle. I hope I have simplified the rotational motion. Yes guys, hope you understand. Okay, so I hope I have simplified the rotational motion, right? Now let's go for the uh, last motion, that is general motion. General motion. Now let us move for the general motion, right? Now here see that what is general motion, right? So the body is translate or the body translate and also rotates, okay? So here in general motion the body translate, the particles of the body, not body, because we are studying the particles, na? The particles of body translate and also rotates, right? Now here I will give you the two statements, right? So in past cases what we have studied in the past case, so in the first translation paths are parallel to each other and velocity of the each particle is same. In rotation motion paths are parallel and velocity of the particles are also same. In rotational motion, though the particles are moved in a curved manner, but their displacement, their velocities are different, right? Here what happened now? So the particles of the body having different paths and each particle having different velocity, that is come under general motion, okay, right? Here the body particles having different shape, different paths, that means while they are moving they have a different paths, all the particles are having different paths and also all the particles having different velocities, then it is considered as a general motion. I hope you understand. With the help of example also we will study, not an issue, all right, right? Now here, so all the particles of body, okay, moves in a different paths, okay, right? That means each and every particle having different paths, right? Similarly, one more thing I would like to highlight, the particles of the body, right, having different velocities, have different velocities, right? Then it is considered as a general motion. General motion, in simple words we can say that it is a combination of rotation plus translation, right? Now all the particles are having different paths and also all the particles having different velocities. Now let us see one example in order to understand this, okay, right? Right. Now let us go for see one example in order to understand this. Now firstly I consider a body and here I am taking again particle 1 and particle 2. So particle 1 and particle 2. Say this is a distance between the particle 1 and particle 2. So after that this body reaches over here. This body reaches over here, right? Now my particles are is at 1 dash and it is a 2 dash. Now my body position is over here like this, right? Now distance between these two is like this, right? Now what is my actual position of the body here? Okay, if I able to draw, right, my body position here, this body, isn't it like this, right? So now what I'm trying to tell you, what I'm trying to tell you, right? Now, see, my second part is in translation, right? My second particle in the body is in translation, right? It is moved like this, right? Now, my first particle of the body, this is a first particle, second particle, right? Now, if I draw this, my first particle is here. My first particle is here, right? Right, try to understand. This body I just placed over here, okay, right? So now from here it reaches to 1 dash. Now it is going to be a 1 dash. It is a curved linear. That means here it is a rotation, na? So first particle is moved in a translation path and second particle moved in a curved line. Okay, now here it is a, so it is a translation and this fellow is a rotation, right? So the body A is going to be moved over here, right? Now in that case I consider my initial shape of the body. Now second point is in translation and first point is in a rotation motion. So I hope I have simplified. Here the velocities are firstly translation. So firstly translation from 2 to 2 dash, it is a translation, right? So now here I'll write 2 to 2 dash is translation, right? Now secondly 1 to 1 dash is a rotation. 1 to 1 dash is a rotation. Clear everybody, guys? Translation as well as the rotation. Now the combination of translation and rotation motion, we can simply say that it is a general motion. I hope everybody understand. So particle 1 velocity is different, particle 2 velocity is different, particle 1 path is different, particle 2 path is different. Here particle 1 path is like this, translation, and particle 1 part is going to be a curved path, okay, or rotational motion. All right, so hope you everybody understand, guys. Hope you understand. So what are the different motions of the body? So that is, I have described 3 types, translation, rectilinear and curvilinear, and also rotation and also general motion, right? Now here I would like to highlight and summarize in a simple way. That is, in translation motion the paths are parallel and velocity of each particle in the body is equal when the body is in motion, right? Now similarly in rotation motion, what happened now, though the particles of the body moved in a curved path, then but the velocities of the particle is different, right, in a body when it is in motion. Similarly general motion, in general motion when the body is in motion, so the particles of the body having different velocities and also different paths is come under general motion. So with the help of examples I have described everything in a simple and easy way. All right. Right. Now let us move for the next concept, is that dynamics of particles. Dynamics of particles. First we'll highlight that dynamics of particles. Dynamics of particles. Dynamics of particles. Right. Now dynamics of particles. So when we can say, first we need to understand that what is dynamics of particle means. Dynamics means when the body is in motion. But what is mean by particle? What is mean by particle? So that you need to understand. Okay, right. First you need to understand particle, then we go for dynamics, kinematics of particle and kinetics of particle. We will see that, right? Now let me introduce you what is particle. The size and shape of the particle have no effect on the motion of the body, then the entire body considered as a particle, right? I hope you understand, right? I'll just simply give you that if the size and shape of the particle have no effect on the motion of the body, when it is in motion, then all the body is considered as a particle, right? Now let me write and give you one example as well. Okay, right. Now let me write that, right? If the size and shape have no effect on have no effect on the motion of body then all the whole the body considered as a one particle. Whole body consider as a particle. All right, right. When we consider it as a particle, so that is what I would like to highlight. Okay, right. Now, suppose I am taking a body. So with example, I'll explain you guys. I am taking a body, right? So it is moving with certain velocity. Say that it is moving with certain velocity, right? Now it is moving with certain velocity, say v, and it reaches finally to this position after some time. Okay, isn't it, guys? Okay, so the body is moving with certain velocity, and after some time it reaches to certain position, right? Now here say that, so with the v it is moving, right? Now if I take particles 1, 2 and 3, say this is a particle 1, particle 2 and particle 3, right? So when we consider a particle, so if all the particles are, so these particles are moving with the same velocity and same displacement, and say that this body mass is 100 kg, and so with this 100 kg mass body, and it is moving with a V1, V2 and V3. If suppose V1 equal to V3, V2 equal to V3 and so on, that means how many particles you consider, then all the particles are having the same velocity, then the mass of the body is not affecting on the velocity, the shape of the body is not affecting on the velocity, then the shape and size of the body is not affecting the displacement also. That means here V1 equal to V2 equal to V3. Now here displacement S1, S2 and also S3. Here also, now here I can write S1 is equal to S2 is equal to S3. But here the mass or the shape of the body is not affecting the velocity as well as the displacement. So that is why, so this kind of thing we are considering it as the whole body, we consider it as a particle. Okay, because of the mass, because of the shape, it is not going to be changed, isn't it, guys? Now that is why here we are considering it as a particle. So particle, what is that? This body is whole body considered as a particle, right? Now do remember, guys, this is valid for only translation motion. Okay, this valid for only translation motion. Okay, this is valid for only translation, isn't it, guys? So particle, the body is assumed to be a particle when it is in translation motion, right? In translation motion only S1, S2 and also V1, V2, all particles of the body is equal. That is why it is not considering it as a kinetic, particles, right? Right. Now here the same, if you study the rotation motion and also general motion for the bodies, right? Because the velocities are different in the bodies, right? So here if you study the particles, translation motion only for particles, but if you study the rotational motion and general motion, then it is come under rigid bodies. All right, guys, I hope you understand. Right, guys, hope you understand. Now let us move for motion variables. Next our concept is motion variables, right? Next our concept is motion variables. motion, kinematics of particles. In that, motion variables we will study. Kinematics of particles. Kinematics of particles, isn't it, guys? Right? Now here, kinematics of particles. Okay, right. Again, kinematics, we have a translation motion. In that, rectilinear as well as the curvilinear motion we have. But here, so in without forces, kinematics of particles means study the motion without considering the forces. Okay, study the motions of body, without considering forces. Without considering forces. Yes, guys, I hope you understand. Right? Now, in that, we will going to study rectilinear motion as well as the curvilinear motion. So, translation motion, we use curvilinear as well as the rectilinear motion, right? Sorry, translation motion, in that curvilinear and rectilinear we are going to okay. Good evening Atul sir, thank you. Right, now let us move for motion variables. So what kind of motion of a body we need to study, what are that variables? Right, now let us see that motion variables. So motion variables, all right guys. Now here what I would like to highlight, guys, so these fundamentals are very essential for you to go for the GATE 23, 24, sorry 24 and 25. Why? Because see, so if you understand these basic kind of definitions and as well as the characteristics and these variables, so that it is very easy to you to go for the depth of the engineering mechanics. Right, now first motion variable is that it is displacement. First motion variable is displacement. Right, first one is a displacement. First motion variable is displacement. So generally we indicate displacement with S, right? Right. Now let me define you. Change in the position of the body when it is in motion, it is come under displacement. Okay. So now change in the position of body or particle is come under displacement. Right. Now let me write that. Change in position of particle or body when it is in motion, called displacement. Yes, guys. Right. So change in the position of a particle or a body when it is in motion, it is considered as a displacement. Okay. Hope you understand, everybody. Hope you understand. Right. Now let us see that. With one example. Right. See. So now let us see this. A body. Let us consider a body. It's here like this, right? So after it reaches over here, again it reaches over here, right? Now here it is a first position, that is origin. Okay, so origin here. Now, so from the origin with certain velocity, the body is moved over here, right? Now from this fellow we are calling it as say S1. Okay, right. So after that the body again moves from here to here. Here say it is a S2, right? So first position of the body and then second position of the body, and it is moving with certain velocity, say that V, right? So now the body is moving from the origin with the velocity, it reaches the first position and then second position, right? Suppose first position, and after some time it reaches to the second position as well, right? Now here I said that change in position of a body when it is in motion, that is considered as a displacement, right? Now here my displacement, I will write it is displacement is equal to, it is gonna be a, how much it is? So S2 minus S1 is our displacement of the body from the first position to second position, right? So initially it is traveled, but the displacement from the first position to second position is S2 minus S1. This is what the displacement. However, first displacement we can say S1, second displacement it is S2, right? Now the displacement between the first position and second position, then we can say that it is a S2 minus S1. So clear everybody? I hope everybody understand. I hope everybody understand, right? Right. Now let us go for velocity. Next motion, first motion variable displacement, second motion variable is a velocity. Second variable motion is velocity. It is indicated with V, right? Right. Now it's a very simple definition. The rate of change of displacement with respect to time is come under velocity, right? So rate of change of displacement is come under velocity, right? Rate of change of displacement called velocity. Yes guys, rate of change of displacement is called velocity. Clear everybody? Right. Here I can write my velocity is equal to here ds by dt. So I will going to get my velocity, right? So rate of change of displacement with respect to time is come under, velocity, right? Now next go for another variable, that is, motion variable is third motion variable, acceleration. Generally we indicate with A, acceleration, right? So what is acceleration? Rate of change of velocity is come under acceleration. That's it, very simple. Rate of change of velocity is considered as acceleration. Rate of change of velocity, called acceleration. Isn't it guys? Rate of change of velocity is called acceleration. Clear everybody? I hope everybody understand. Now let us see that. Here what happened, right? Now my acceleration is equal to dv by dt, right? Now again in place of that I can write it is d of dt into, in place of v, how can I write it is d of ds by dt, right? Finally I can write my acceleration is equal to, it is d square s by dt square, d square s by dt square. Yes guys, hope you understand, right? Clear everybody? Right. Now again I can write it is, see, have a look on this again. Now here acceleration is equal to, it is dv by dt, right. I will write this fellow, it is dv by ds into ds by dt, right. Now here ds by dt is v into, it is dv by ds. So like that also we can write velocity, sorry, acceleration. I hope everybody understand. I hope everybody understand, guys, right. Now right. So this is how we need to calculate velocity, acceleration as well as the displacement, right. Next our concept is uniform acceleration motion, right. Next our concept is, oh my god, uniform acceleration motion, right. Uniform acceleration motion, uniform acceleration motion, right. This we call it as UAM, okay, uniform acceleration motion. So when we call it as a uniform acceleration motion, okay, so when a body moves with a constant velocity, then we consider it as a uniform acceleration motion. That means acceleration is constant, okay. When the body is in motion, if the acceleration is constant and if the acceleration, no change in the acceleration, then it is considered as a uniform acceleration motion, okay, right. Now let me give you that. If a body moves with, the body moves with constant acceleration, the body moves with a constant acceleration, then it is considered as a uniform acceleration motion. Clear everybody, guys? Right. Now here right. Now let us see that in order to calculate this, we have a three basic equations, okay. In order to solve these kind of problems, when the acceleration of the body is constant, when it is in motion, then we have a three kind of formulas, okay. Now let us go for, so see one by one, okay, right. Now first, three basic equations, what are those? Okay. Now let us go for the first one. Right. Now see, suppose my body is at position 1, right. Now it's move with certain velocity and acceleration, reach to the second position, right. So my particle is moves with a certain velocity and reaches to the position 1, okay. Now what is the displacement? So here the displacement is, say that S, okay. Now here the displacement, I say that it is a S. The displacement is S. Under the action of forces, my particle moves with certain velocity from rest position to second position over here, right. Now here what is my velocity at the initial? It is a U. Initial velocity is U, okay. So my origin position. Now at the second position, my velocity is a final velocity, right. So S is a displacement, and you know U is a initial velocity, right. V is a final velocity, isn't it, guys? Clear everybody, right? So hope you understand, right. Now here, so let us go for take the equation of A. So what is A? A is equal to, it is a dV by dt, yes. dv by dt, right? Now can I write it is dv is equal to a into dt, right? So if I integrate this, right? So now dv is equal to integrate a into dt, isn't it, guys? Right? Now, so actually what is my initial velocity? U. What is my final velocity? V, right? Now my initial velocity is u and my final velocity is v, right? Now here what is my time? Initially my time, so t equal to 0. Now here t equal to, I'll take it as a t only, right? So initial t1 is equal to 0, t2 is equal to t, right? So in the beginning displacement is equal to 0. Now here that means initial displacement is equal to 0 and final displacement s2 equal to say s, right? Right. Now here what is my time here? Right, time is 0 to t. So now we assumed that acceleration is constant, right? Constant acceleration. So since a is equal to constant, right? Now here how can I write this? Guys, right? Now so integration of this fellow is u only, v only will get. Now here it is going to be a v minus u is equal to a integration of 0 to t into dt, right? Now here I can write it is v minus u is equal to, it is going to be a at. All right, guys. So u minus v equal to at. Now here I'll write my final equation, right? Now here v is equal to, it is u plus at. So this is what you are supposed to select. Okay, this is what you are supposed to select, right? This is a first equation, first relation in the constant acceleration. Okay, now I'll write it as a first relation, right? So by using this relation only we are going to calculate v equal to u plus at. For this deriving that, nothing I have done, guys, nothing I have done. Very simple and easy I have done. What I have done, so I have taken one particle. So this particle position initially it is at one position, it is in rest. Under the action of forces it is moving with certain velocity and reaches the second position, right? Now so initially it is having velocity v, right? Finally it is velocity having u, right? At t1 equal to t is 0 and tt equal to time is t. Now here s1 displacement is equal to 0 and here displacement is equal to yes, guys. Now from there I have taken acceleration, so equation, from there I have derived this and I got the relation v equal to u plus at. Okay, guys, hope you understand, right? Now let us move for the second relation. Right, for the second relation, if it is a simply I'll write second relation. You need to remember all these relation, you know, so in a very easy manner. Why? Because these are very important. Okay, right? Now here I am going to take here v is equal to, it is ds by dt, right? V is equal to, it is ds by dt, right? Now here I'll write my equation, ds is equal to, it is v into dt. ds is equal to vs into v into dt, right? Now if I integrate my equation, it is going to be a ds is equal to, it is v into dt integration, isn't it, guys? Right? Now here see, now here, so v is not constant here, right? Now we have found now what is v is equal to, u plus at. I'll substitute, right? Now here what are the limits? 0 to s and here it is 0 to t, right? Now from there integration of 0 to s ds is equal to integration 0 to t is equal to, it is u plus at into dt. Yes, guys, right? So from here I just integrate this. Okay, so what is integration of 1? It is going to be 1, then it is going to be a yes, it is going to become, right? Now integration of u, so here u plus at, right? Now here, so initial velocity is ut only, right? Now if I integrate u, then I am going to get it is ut. Now a is constant na, so plus it is you know, a and t square by 2, isn't it guys, right? Now I'll write my equation, s is equal to it is ut plus half at square. So why? Because my you know, relation, that means my acceleration is constant here, okay, my acceleration is constant here. Now this is gonna be a second relation, we call it as a second relation. Yes guys, hope you understand, right? Second relation, right? So now you got it now. So ds I have taken, in between the limits of 0 to s I have done. Now 0 to t, and in place of v I got u plus at, right? U integration I'll get ut, and t integration I'm going to get it is a t square by 2, right? Now a is a constant, like that I can keep like that only, and I sub, right guys? Hope you understand, right? Now let us move for the third relation. Let us move for the third relation. Right. Next, third relation. Third relation. What is a third relation? What is third relation? Right. Here I am going to get here. So a is equal to, it is v into ds by dt, right? So this we have written at the time of acceleration. Displacement, velocity and acceleration. Here I wrote, look at here. So a equal to v plus dv by ds, right? Now from here, so dv by, it is 1 minute guys, it is dv by ds. I'm sorry, ds by dt I wrote, dv by ds it is. dv by ds. All right. Now I just write it is v into dv is equal to, it is a into ds. A into ds. Yes guys, understood, right? From here, what are the limits? If I integrate this, v into, it is going to be a dv is equal to, it is going to be a integration 0 to s into a into ds, right? From here, so the limits here, initial velocity and final velocity. What is a v of v integration? So you are going to get it is you know, so v square by 2 minus u square by 2, right? Or else I'll write it as you know, if you want one more step, I'll write it as, not an issue, right? Now in this step I'll integrate this fellow, and what I'm going to get here, it is v square by 2 in between the limits of, you know, so v and u, that is equal to, a is a constant na, so 0 to s into ds. Yes guys, right? From here I will write it is v square by 2 minus u square by 2, higher limit minus lower limit, right? A into, you know, s, right? Now here I can write it is v square minus u square is equal to 2as. I'm going to get my relation. All right guys, right? Now here, right? Now this is what the third relation. Say that it is a third relation. Third relation. Isn't it guys, right? So hope you understand everybody, hope you understand, right? Now let us see that you know, right? So now let us write these three relations, and we'll solve the problems whenever the uniform or constant acceleration are there, and that most of the questions are coming like that only. Okay, now I'll write these three relations at one place. Relations of constant uniform acceleration when, here I'll write, when a is equal to constant. When a is equal to constant guys. Yes guys, okay, right? Now what is the first relation? V is equal to u plus at. V is equal to it is U plus AT. V is equal to it is U plus AT is a first relation. Now the second relation is S is equal to it is going to be a UT plus of AT square. UT plus of AT square, right? Now third relation is equal to V square minus U square is equal to 2AS, right? So this is a first relation and this is a second relation, and then third relation when the acceleration is going to be constant, isn't it, guys? So now I hope everybody understand, right? Now let us solve related to uniform acceleration problems, okay, right? Right, have a look on this problem. Have a look on this problem. So I'll give you 1 minute time, try to solve, or else I'll solve this time and next time you have to solve. Right. A car is starting from rest and is accelerated at a rate of 0.4 meters per second, so second square, right? So the distance by the car in 20 seconds is, that means the distance covered by the car in 20 seconds is, okay, right? A car is in rest position and it is accelerated at the rate of 0.4 meters per second square. Now what is the distance a car is covered after 20 seconds? That is what we need to calculate, isn't it, guys, right? Now what is given? When the car is in starting resting position, then initial velocity is 0, right? So now here A is given, A is equal to it is 0.4 meters per second square, and also time is given, that is equal to 20 seconds, right? Now so car starting from the rest, so now initial velocity is equal to 0. Now what we need to find? We need to find, yes, how much distance it has been covered, so by using this parameters, right? So which equation is going to be used? Which equation is going to be used, right? Now let me use that S equal to UT plus half AT square, UT plus half AT square, right? Now U is 0 and then substitute all the values, right? Now S is equal to U is 0 into T is 20 seconds plus half A is, how much A is given now? A is given 0.4 and it is going to be a 20 square, isn't it, guys, right? Now this is going to be 0 and then half into 0.2 into 20 square. Now if I going to solve, then the distance covered by the car is going to be a 80 meters, okay? So try to solve this equation, try to solve this equation. It is going to be a 20 square. All right, guys, I hope everybody understand. Right, guys? So you understand now? So if you very strong in this three equations, so that it would be very easy to solve these kind of questions, okay, right? Now let's move for another question, right? Have a look on this question. I will give you 1 minute time, try to solve. Now let's solve this. Right. Next, solve this. A train traveling at 20 km per hour is accelerate at a rate of 0.5 meters per second. The distance traveled by train in 12 seconds is, it is also similar like previous case. Now here you need to understand, one thing guys, very important. Most of the students are not going to be remember this, right? So 1 kilometer per hour is equal to, it is 5 by 18 meter per second, right? So whenever you just have a value of velocity in terms of kilometer per hour, then you just multiply that with a 5 by 18 so that it is going to be converted into meters per second. I hope everybody understand, right? Now here the train traveling at 27 kilometer per hour accelerate at the rate of 0.5 meters per second, and the distance traveled by the train in 12 seconds is, right? Now here, so final velocity, acceleration is given, that is acceleration is equal to 0.5 so meters per second square, right? Now here v is given, that is velocity of train is given, that is it is not in rest position, that is why I am taking it as a final velocity, right? That means it's moving with a certain velocity. All right guys, right? Now here it is going to be a kilometer per hour, right? Convert this fellow. So 27 into 5 by 18, right? Now you are going to get it is let me know that 7.5 meters per second. 7.5 meters per second I am going to get. And what is given? So time is also given, right? So that is 12 seconds guys. That is 12 seconds. So now what is the relation we have when we have a acceleration, when we have a v, and when we have a t? Okay. So now here, so I'll use the relation s equal to ut plus half at square. Okay. So I'll use a relation that, so s is equal to ut plus half at square. So because I need to determine the displacement, right? I know the velocity. What is the velocity? 7.5 into, so time is 12 seconds. Time is 12 seconds plus half into a. How much a is given guys? Oh my god. How much a is given? 0.5 meters per second square. 0.5, and then again it is going to be a 12 square, right? Now solve this guys, and then let me know the displacement. Solve this and let me know the displacement. All right. Now you are going to get it is according to my calculation, it is 126 meter. I am going to get 126 meter, isn't it guys? Right? Can we have one more problem? See how I have solved. So this is very important guys. This is very important. Try to remember this. Right. Have a look on this problem. Another problem. Right. So I will give you 1 minute and try to solve. Yes, solved. Hi guys, did you solve? Anybody? Anybody solved? No. Oh my god. Right. Now let me solve myself. A scooter starts from rest and moves with a constant acceleration of 1.2 meters per second square. Scooter is starting from where? Rest position, right? Whenever it is starting from the rest position, then initial velocity of the scooter is 0. All right. Now let us move for next statement. What is that? With a constant acceleration and determine the velocity in meters per second. However, we know that initial velocity is 0. Why? Because it is starting from rest. All right. Now what velocity we need to find? Final velocity we need to find. Okay. So next. So when we have to find the velocity after it is traveled from 60 meters, right? After it is starting from 60 meters, right? So right guys, so what I am trying to explain, you guys try to do understand. Whenever you encounter such kind of questions, then immediately what you need to do now, write the given data and understand the statements of question, right? So that it would be very easy for you to solve, right? Now here, according to the problem data, I will write it as, so scooter starting from rest, right? U equal to 0. Since it is starting from rest. Starting from rest. All right. Since it is starting from rest. Now it is moving with a constant acceleration, that is 1.2 meters per second square, right? So now, and S is given, that is equal to 60 meters. All right. Now what we need to find? Final velocity we need to find. Now by using this data, what formula we have? What formula we have, right? So now as I know, because of my derivations, I understood one thing, that is, V square minus U square is equal to, it is going to be a 2as. V square minus U square is equal to 2as, right? Now from here, as I know that V square is equal to 0, now V is equal to 2as under root. From here, it is going to be a 2 into 1.2 into 60 under root. So now let me know this value. Let me know this value. How much it is? So you are going to get it is at 12 meter per second. 12 meter per second. Make sure that guys, okay, make sure that all the units are in same, okay. Make sure that all the units are in same, right? Now here, so we have solved the problems based on the three relations. So what are that relations, guys? Right, is that, so V equal to U plus AT. V equal to U plus AT is the first relation, right? Next second relation is, what is that? UT plus half AT square is the second relation, right? Now, V square minus U square is equal to 2as is the third relation, right? Here U is the initial velocity and A is the acceleration, T is the time, and V is the final velocity. Let me write these terminologies also. It's a very good, actually, good idea, right? Now here, so U is equal to, remember these guys, U is equal to initial velocity, right? V is equal to final velocity, right? Now here A is equal to acceleration, and S is equal to displacement, right? And then T is equal to time. Isn't it, guys? Right? Now, so these are the things, so what we have discussed today, right? You just focus on these three equations. How can we use? We will solve different number of problems in the tomorrow class, and we will move forward for the dynamics of rigid bodies as well. Okay, hope you understand, guys. Thank you. So now the session is going to be end. Thank you very much.